Now, this is a very interesting topic, that is generalization versus specialization. This is related to inheritance. So, what is this? Let us understand. See, I have a class called rectangle. I'm continuing with the same example because I don't have to explain you the examples again. So, I'm continuing with the known example only. This class we have defined. Can you create the object of rectangle? Yes, object of rectangle you can create, and you can use it. You can call the functions like area and perimeter. And next, there is a class for cuboid, and this is inheriting from rectangle. For cuboid also you can create the objects and you can call the functions of cuboid. Now these two things really exist in the world. Can you show me a rectangle? Yes, you can show me some shape, something, or just a plank that is a rectangular plank, or a paper that is rectangle, window pane that is rectangle. So rectangle exists in real world. And what about cuboid? Yes, it also exists in real world. Any box, alright, any box shaped thing is a cuboid. So these two things exist in real. Now in this, if I say which was existing first in our example, this one or that one? A rectangle was existing. From there we have derived a cuboid. So this class is already existing and we have defined a new class with extra features. So we have a specialized class that is cuboid. This was already existing, then we created a new one. So this is specialization. I'll take an example of some car. I don't know whether those models are available everywhere or not. Let us take an example. I have a class called Innova. Innova car from Toyota. Then there is a class called Fortuner. So if you have the idea of this one, Toyota company has launched Innova car first, then they have launched a new car that was Fortuner, which is extension of Innova. So as a common man, if you see, it's an extension of Innova. So it's having same seating capacity and everything, and with lot of extra features in that one. So it means that Fortuner car is a extension of Innova car. So this is a base car class and this is a derived class, and that was already existing, and this is a specialized Innova, so that is Fortuner. So this is specialization. Something is already existing, then you are deriving something from that one and defining a new class. This is specialization. From real world you can take lots of examples of specialization where this also exists in real world, this also exists in real world. You can show the existence of this one. You can show many cars on the road that are Innova cars and many cars on the road that are Fortuner car. Now let us take another example. I have a rectangle, I have a circle, I have a quadrilateral. Then for all these I am defining one class called shape. This is inheriting from this one, this is inheriting from this one, this is inheriting from this one. Now what is this? Which was existing first? This rectangle really exists, circle really exists, quadrilateral really exists, and these all I am calling them as shape. Do you think shape really exists in real world? No. Then it is just a virtual term. It's not a real term. It's a virtual term. If I ask you, show me some shape, you will be drawing a rectangle or a circle or a quadrilateral or trapezium or rhombus or something, but you cannot show me just shape, right? So shape is a virtual term, a generic term, generalized term. So yes, when these classes, child classes were already existing, then to bring them on a common platform, we have given a word shape, which is logical term. It's not real term, not physical term. Can you find area or perimeter of a rectangle? Yes. Can you find area perimeter of a circle? Yes. Can you find area and perimeter of a quadrilateral? Yes. Does the shape, every shape have area and perimeter? Yes. That is the common feature we have brought it into shape. Now you calculate area and perimeter of a shape. You can't. There are no dimensions for shape, right? It's a generalized term. So this is an example of generalization. This is an example of generalization. So I'll give you one more example similar to this one. Let us take Innova, right? You can start, stop, you can change the gear, you can accelerate, so and so things. Now, next is Swift. You can start, you can change the gear, start and stop, you can accelerate, various things you can do here. Next, Corolla. You can start, stop, and you can accelerate, you can change the gear. What these are all? These are cars. These are cars. Yes. All these are cars. Can you show me a Innova? Yes, it physically exists. Can you show me a Swift? Yes, really exists. Corolla car, that is also again from Toyota, it also exists. Now, all these are nothing but car. Car. Yes, they all are inheriting from car. So what you can do in a car? Car means you can drive it, you can start and stop it, and you can accelerate, you can change the gear. All those features are available in all this. Then what is this car? Does it really exist? No, this is a general term. Just a general term. That is logical definition of a group of things. So group of classes, we have given a superclass, that is base class, easy for referring something. It is just like if I am looking at Innova, I can say car. If I am looking at Swift, I can say it's a car. Corolla also, I can say it's a car. So for many four-wheelers, we use the term car. So I am using this term for referring them. I don't have to know the brand name or the product name perfectly. When it looks like car, I can say it's a car. So that is easy for communication in real world. So in real world, daily life, we define such general terms. So we conclude here. Let us see. This is what inheritance. This is what inheritance. What is this inheritance? What is this inheritance? But what was existing? So I have two different examples. So this portion is separate and this is separate. Who was existing here? This was existing, then we derived this one. This was existing, then we derived this one. So parent was existing, child was defined later. So child borrowed many things from the parent. Child borrows many things from the parent. Now, who was existing? The child classes were existing, then we define a base class. Child classes were existing, then we define a base class. So this is top-down approach, that is specialization. This is bottom-up approach, this is generalization. This is generalization. Here the base class has something to give it to child class. Here the base classes doesn't have anything to give to their child classes. They doesn't have anything. So they don't have anything to borrow here. Just their purpose is to group them together. That's it. So that we can easily manage all those things. Now the last thing that I have to tell you is, why did we achieve generalization? Purpose. You saw Innova, said it's a car. Swift, it's a car. Corolla, it's a car. So you are using same word here. So this is nothing but polymorphism. Same name but different objects or different actions or different things. That is nothing but polymorphism. Shape. It's a rectangle. I said shape. There is a circle. I said this is a shape. And this is a quadrilateral. I said this is a shape. So the idea here is that same word shape I am using, I am referring to all of them, and I calculate area of a rectangle shape, so I get a different formula, and this shape I get a different formula because it's a circle. So the actions are different but the name is used is same. So the purpose of generalization is to achieve polymorphism, and the purpose of specialization is to share its features to its child classes. So the purpose of inheritance is two. One is to share its features to child classes. Second is to achieve polymorphism. So purpose of inheritance is two. Got it? So here I have given you the clear idea what is specialization, what is generalization. So based on this, I will take some example code and I will discuss on that one. So that's all about specialization and generalization.